last night's homework. So I gave you page 155, 7, 8, 9 and 11. Right, okay. Does anyone need me to do number 7? Nope. Anyone for number 8? Nope. Anyone for number 9?
Yeah, please. Yeah.
Number 9, right, okay. And now I open the right page and get myself organized here. Right, okay. Right, number 9. So, right, Ella wants to have 5,000 euros in 3 years' time. So she wants 5,000 euros in 3 years' time. She invests in an annuity that pays out 7.2% per year, compounded quarterly. So 7.2% per year, but we need to do it quarterly. Where am I? I'm reading wrong. How much does she need to deposit? Right, first thing I need to do that is change that to quarterly. Okay, because it's per year, right, but I need to change it to quarterly, per quarter, what percent per quarter. So if I put in 100 euros, after 1 year I would have 107 euros 20. So the principal is equal, the final amount is equal to the principal times 1 plus I to the power of t. So the final amount is 107.20. The principal is 100 euros, right? That's 1 plus I is the quarterly interest rate, which is what I'm trying to figure out. And it was 1 year, so that's 4 quarters. Okay, then that's 1 plus I to the power of 4 is equal to 107.20 divided by 100. Then get the 4th root of each side to get rid of that to the power of 4. So you'll end up with 1 plus I is equal to 4th root of 1.072. Oh dear God. 1.072 equals 1.017 1.01753. So then bring over the 1, so you get the interest rate is 0.01753. Okay, and I can leave it as a decimal because didn't actually ask me to calculate it. Okay, so then I want the quarterly so I want to end up with 5,000. Okay, so she's going to put in a certain amount, right? Okay, and she's going to get the first year's interest. Then she's going to get put the second year amount, and that's going to be in for 2 years. And how many years does she need? 3 years time. Sorry, 3 years. I forgot I have to do it quarterly, don't I? 3 years is 12 quarters. Okay, so she's going to put in an amount per quarter and get interest on it. Then find the final one, the first one she put in will actually be in there for 12 quarters. Okay, so and when she does all that, she wants to end up with 5,000 euros. Okay, so we do Sn. So Sn equals A times 1 minus r to the power of n all over 1 minus r. So Sn is how much she wants at the end, which is 5,000, right? A is the first term, which is the amount she's going to save per quarter multiplied by 1 plus I, right? Then we have 1 minus r is, 1 plus I is 1.017533, so that's r, so that's, what am I have to do there? That should be multiplied by 1.0175, and here I have 1 minus 1.075 to the power of 12, because there's 12 quarters, all over 1 minus 1.01753. Okay, so put this much into the calculator. Okay, so that'll be multiplied by A. So right, I want 1.01753 multiplied by 1 minus 1.01753 to the power of 12, close bracket, all over 1 minus 1.01753 equals, right, so I'm getting 13.45, assuming I put it in properly, right, okay, equals A multiplied by 13.45947, and then divide 5,000 divided by that, okay, equals I'm getting €371 and 49 cents when I round it up to 2 places of decimals. Is that okay? Sorry, that's all over the place. Are we okay? I'll take that as a yeah. Okay, number 11. Anyone need me to do number 11? No? Okay. Are you still there?
Yeah.
Do number 11, is it? Are we okay?
Yeah, please.
Do number 11, right, okay. So, number 11, show how the present value of an annuity involved depositing 3,000 per year in an account for 6 years can be written as a geometric series, given that the interest rate is 8% per annum. Okay, that's grand. So it's 8% per year, and we want 3,000 per year, so we're good. So 3,000, the first one is going to be in for 6 years, right? And the second 3,000 is going to be in for 5 years. And the last 3,000 is going to be in for 1 year. Okay? Sorry, that's 3,001 plus I all to the power 1. So that's a geometric series written backwards. And I know the I is 8%. So I can write that as 1.08. So I'm just going to write it backwards. So it's 3,000 multiplied by 1.08 plus 3,000 multiplied by 1.08 to the power of 2 plus 3,000 3,000 multiplied by 1.08 to the power of 6. Okay, calculate the present value. Okay, so the present value is let's see, the future value. The present value is how much it is now. Okay, so just give me a sec. The future value is present value times 1 plus I to the power of, oh sorry, what am I doing? Right, okay, Sn is how much she's going to save. So that would be A times 1 minus R to the power of n all over 1 minus R. Okay, and this is part 2. Just give me a sec till I think about part 1. Calculate the present value. Future value is this. Calculate it. just leave me do the future value first, and I'll get back to you on the present value. So the future value is how much you're going to have in the account at the end. So it's 3,000 multiplied by 1.08, right? So that's A, right, times 1 minus R is 1.08, all to the power of n, so the 6 there, all over 1 minus 1.08, right, and working that out, we have 3,000 multiplied by 1.08 multiplied by 1 minus 1.08 to the power of 6, close bracket, all over 1 minus 1.08 equals, right, 23,768 and 41 cents. Okay, so that's how much she's going to have in the future, right? Calculate the present value. The present value of that, okay, is I'm confused about the present value. Can I leave present value and come back to you, right? No, I can't, because I have to do part 3 and I need present value. Girls, can I come back to number 11, because my brain has gone dead, so I'm just clued, to be honest. So I'll get back to you on number 11. Okay, is that alright? Because I'm having one of those days, which I have regularly, but I'll get back to you on number 11. Okay, right, I wanted to move on, right, to mortgages and amortization, right, okay, and amortization formula, girls, is in the log tables. You'll be glad to know this. The good news is it's in the tables on page 31. The bad news is you have to be able to derive it yourself, okay. So it's called, on page 31, it's called amortization, right? Okay, so what amortization is how you pay a mortgage, right? Okay, so every month you pay a certain amount, right? Okay, and that's the monthly interest. So you pay the interest and you pay a bit off the principal. So you're paying. Yeah, sorry. No, sorry. Okay, so this is me scribbling here at the bottom. So your payment every month when you get a mortgage, and you've all that to look forward to, your payment every month will be the interest on the loan. So you'll pay the interest on the loan plus a little bit of the principal. Sorry. That's supposed to read little bit off the principal. Okay, you don't need to write that down now. That's just me explaining what amortization, which is what they call it in the book. So if you were got a mortgage for 200,000, right? Okay, and your payment every month was, we just say it's 5,000. Okay, I'm rounding everything up here. So you got a mortgage for 200,000, and every month you paid off 5,000 of that, right? Okay, what it would be is you'd probably be paying something like 3,000 interest, and 2,000 would come off the loan. So after the first year you'd only owe 198,000, right? And after the second year a certain amount would come off that would be interest, and the rest will come off the loan. We'll see it when I do an example. Okay, but that's what amortization, that word, means. Okay, means that you're paying the interest and a little bit off the principal. Okay, so you'll here in when there was when we were in recession or something, some banks made allowances for people to pay interest only off the loan. So their loan was never getting smaller, but they were paying the interest every month. Okay, so their payment was less, but the actual loan wasn't getting smaller. They would just pay the interest every month until they got back on their feet. Okay, right? So that's what amortization means, right? The amortization formula is in the log tables. It's on page 31, and that's what it looks like. Okay, that's P times I times 1 plus I to the power of t times 1 plus I to the power of t minus 1. Okay, again, I is the interest rate, T is the time, P is the principal, as in how much you borrowed, and A is your monthly payment. So A is your monthly payment there. Okay. So to work out what your repayment is, so A is the repayment. Now in the log tables it says annual repayment, but it could be monthly repayment if you change the time to months and the interest to a monthly interest rate. So if it's years and a yearly interest rate, it's per year, your repayment per year. But if it's in months and it's a monthly interest rate, I is a monthly interest rate, then it's your repayment per month. Okay, so as I say, the formula is in the log tables, but you have to be able to derive it, okay, to come up with it. Okay, so if you break down your mortgage, right, okay, when you repay your mortgage, you're going to pay the amount you borrow, right, plus the interest, okay? So your mortgage, right, what you borrow, you might pay 200,000, but you're going to pay back a lot more than 200,000, right? So your mortgage, right, is what you borrow. So I borrowed 200,000. Is each monthly payment, and you have to take the interest off the payment, okay? So you take the interest off the payment because that's going to pay the interest on the loan, right? So if you take the interest off the payments, that's what your mortgage will sum up to, okay? So your you have to pay the mortgage plus the interest. So if you take the interest off each of your payments, right, okay, that'll should total up to your mortgage, okay? So your first repayment, right, sorry, your first repayment is actually the last one here. So your first repayment, girls, you're going to take 20 years interest off it, right, okay? And your second repayment, etc., and so on, right? Okay, that's a geometric series, right, where A is the first term. So A is the payment is A, it probably should be repayment, your monthly payment, right? A all over 1 plus I, I'm just going to call that A, right? And R is what you're multiplying by, so you're multiplying by 1 all over 1 plus I all the time, okay? So then we've kind of done this before, but now I'm just doing it specific to a mortgage or a loan, right? Okay, so Sn, right, equals A times 1 minus R to the power of n all over 1 minus R. So that means Sn, which is going to be your mortgage, because when you add up all these repayments, right, and the interest, that's going to be your mortgage. So we have A is capital A, which is your repayment, divided by 1 minus I, all over 1 minus 1 all over 1 plus I, all to the power of T, right? T is the term of your loan, right? All over 1 minus 1 all over 1 plus I. Okay, so Sn is actually, this is your mortgage or your principal, right? Your principal is how much you borrowed, 200,000, 150,000, whatever. Okay, now what I have to do is I have to manipulate, I'm basically done, but I have to manipulate that, right, okay, to look like the formula I just wrote down up at the top. So I just have to play around with that to make it look like that. So I need to manipulate this so it's really just algebra. So to A equals P times I times 1 plus I to the power of T all over 1 plus I to the power of T minus 1. So that's what I'm trying to do. So I'm basically just manipulating, right, I've the hard work done, so I'm just manipulating it. Okay, is that right? Okay, so I need more board now, so can So what we do is, right, okay, I'm going to take, what am I going to do? I'm going to get a common denominator underneath the line first, okay? So all over 1 plus I, so I'm just leaving above the line as it is, except I'm just going to change that to 1 plus I to the power of, no, I'll leave it, okay? Right, underneath the line I'm going to get a common denominator. So that would be, that's over 1. Common denominator is 1 plus I, right, okay? So 1 into 1 plus I goes 1 plus I times minus 1. So I just put that 1 over the 1 plus I as well, okay? So I'll end up with, they'll cancel, so I'll end up with the principal equals A times 1 plus I all over 1 minus 1 plus I all to the power of t all over I all over 1 plus I. Okay, right, can I move it up? Right, once you get to there, you multiply above and below by 1 plus I and multiply above below by 1 plus I. So you're really not changing it. So you're multiplying, I'll make that look more like, multiply this line by 1 plus I and multiply this line by 1 plus I. Okay, so what happens when you multiply above and below by 1 plus I? The 1 plus I here cancels with this 1 plus I, and this 1 plus I cancels with this 1 plus I, and you're left with P is equal to A times 1 minus 1 all over 1 plus I to the power of T all over I. Okay, now I want to rearrange it so I have A equals, so I'm going to cross multiply. Right, so I'm going to cross multiply, I need more board. Right, so cross multiply, I'll get Pi is equal to A times 1 minus 1 all over 1 plus I to the power of T. That's it. Okay? Right, okay. So then I want A equals, so that means A equals Pi divided by 1 minus 1 all over 1 plus I to the power of T. And then I want to get rid of this fraction underneath the line. So I'm going to multiply each term by 1 plus I to the power of T. Right, just to get rid of that fraction. I might change that just to, that would be 1 to the power of T, which is just 1 all over 1 plus I to the power of T. Okay, so I'm going to multiply each term by 1 plus I to the power of T. So that means A is equal to Pi times 1 plus I to the power of T. Multiply that by 1 plus I to the power of T. And multiply this one by 1 plus I to the power of T, and it'll cancel and you'll just get minus 1. Right? And that's it done. Okay, that's the formula the way it is in the first one. The only difference is the P is out at the front, but that's the exact same thing. Okay, so we're done. Okay, now there's a bit of thinking about that, there's a bit of manipulation in that, so I suggest you sit down and try and do it yourself, right, and see what you can come up with. Okay. right? And I had two examples, but I'm only going to do one because that took me ages, right? Okay, why have I example 2 first? Just give me a sec. Example 2. Put that aside for tomorrow. Right, example 1, right, is just filling out the formula. Okay, so Dermot takes a mortgage of 180,000. Annual percentage rate is 4.5%. Find the equivalent monthly repayments. Okay, so I need monthly repayments, girls, if the mortgage is to be repaid over 20 years. Okay, so I need monthly repayments and I have a yearly rate. So the first thing I need to do is change the yearly rate to a monthly rate. So the yearly rate is 4.5%. So that means if I put in €100, after 1 year, I would have €104.5. Okay, so final amount is equal to the principal times 1 plus I to the power of t. Final amount is 104.50 equals the principal is 100 times 1 plus I. I is the monthly interest rate, which is what I'm trying to find out. Now the time is now in months, so it's 12 months. Okay, right, manipulating all of that, right, okay, I'm just going to not write out the manipulation, I'm just going to give you the answer. Okay, so shift and that, the 12th root of 1.045 equals, right, and take away the 1 then. So the interest rate is 0.00367.5. Okay, so I've rounded it up there. Is that alright? That's the monthly interest rate. Okay, so now I can fill out the formula, okay, which I just happen to have written there, which is great. So the monthly repayment is equal to the principal, right, which is how much I borrowed. So he borrowed 180,000 multiplied by I, which is 0.00367.5 multiplied by 1 plus 0.00367.5. Now all to the power of time. Now we're doing months, so 20 years, girls, is 240 months, isn't it? 10 years would be 120 months, yeah. So, right, make sure your time is in months. Everything has to correspond. Monthly repayment, monthly interest rate, time in months, okay? All over 1 plus 0.00367.5 all to the power of 240 minus 1. Into the calculator with that then, okay? 180, 123, open bracket, 0.00367.5, close bracket, open bracket, 1.00367.5, close bracket to the power of 240, right? Underneath the line I have 1.00367.5 to the power of 240 and minus 1 equals, into the calculator with that, and you will see that the monthly repayment rates are 1,130 and 4 cents, assuming I've typed all that in correctly. Okay, is that alright? Now, I know that's like I just spoke Japanese for the last 40 minutes, right? Okay, so what I'm going to ask you to do is if you just have a go at page 157, have a go at 1, 2 and 3, right? Have a look at the proof of the formula again, right? See, can you make head nor tail of it, right? Okay, and I'll get back to question 11 tomorrow because I just got a blank mind there, right? Okay, so page 157, 123. Look at the proof, see can you work out what actually happened, right? Okay, and then do 157, 1, 2 and 3. So you can head off now and I'll talk to you tomorrow.
Thank you.
Right, bye girls.
Thank you.
Bye girls.
Thank you.
Bye.